Nikola Tesla. Effulgent's glory.
In February 1894, Tesla went with T.C. Martin to the laboratory of Mr. Bettini, an inventor who had advanced Edison's work in the perfection of the phonograph. He wants to display his marvelous collection of song cylinders. Madame Melba, de Resque, Salvini and Bernhardt, Martin wrote.
He wishes the honor of catching your voice as well. During this time, Martin continued to forward reviews from Book News, Physics Review, and London Electrician. Praise from Sir Herbert Spencer is praise indeed, the editor wrote.
Thanks for continuing the Russian translation. The German edition is selling as well. On the home front, Tesla had formed a new company with two of the coordinators of the Niagara project, and he was now turning his attention to designing a wireless system that would be able to transmit light, information, and electrical power.
Thus, the inventor worked to perfect his mechanical and electrical oscillators and vacuum lamps.
The mechanical oscillator could efficiently convert steam to electrical power. The electrical oscillator could produce the frequencies necessary for power transmission. And the wireless fluorescent bulbs could be illuminated when the correct wavelengths were reached capable of engendering light. According to Tesla's theory, if the ether could be made to oscillate at 500 trillion times per second, pure light would be created. Below that figure, heat was produced. T.C. Martin continued to play a role somewhat like a manager. In the spring, he set up a sitting for the inventor before the sculptor Mr. Wolf, and to Tesla's dismay, he also arranged an interview with S.N.S. in McClure, the well-known magazine editor. Tesla had too many events crammed into his calendar, but T.C. persisted.
I cannot very well call of McClure now, Martin wrote, after your little dinner, which has simply made him more eager than ever for the article.
Ending the missive with customary praise, Martin wrote, he knows now personally what he knew before only by hearsay, fears that you are a great man and an honest fellow.
I excuse your blushes. It would take nearly a year for the Century to complete its own article and organize the photographing of the celebrated individuals who came to 33-35 South 5th Avenue. But finally, in April 1895, Martin's follow-up piece appeared.
Even today, a century later, it remains a spectacular testament to the wizard's fabled laboratory. For not only did it display many fascinating inventions and prognostications, it also presented dazzling multiple exposure photographs of such stars of the day as actor Joseph Jefferson, poet F. Mary Crawford, and sorcerer Nikola Tesla. Martin's article should be read very carefully to be appreciated, Tesla wrote Johnson. With 35 homes illuminated by gas for every one lit by electricity, the market was ripe for a more efficient source. However, Tesla's fluorescent lamps were still in an experimental stage, as evidenced by the 10-minute time-lapse photograph of Mark Twain taken for the Martin article. The story for Tesla's steam dynamo was analogous.
According to Martin's figures, 9/10 of all dynamos in the country were steam-driven.
The rest gained their power from either compressed air, water wheels, or gasoline. Since the Tesla oscillator was 40 times more efficient than the prevailing steam-driven dynamo, it seemed that the marketing of this product would be highly profitable. But again, the perfection of the device was not completed and therefore not yet marketable. Nevertheless, it was revolutionary, and Tesla contacted Babcock and Wilcox to begin manufacturing prototypes. Before a large number of physicians and engineers of the American Electrotherapeutic Association at his laboratory in October 1894, Tesla used the oscillator to generate electricity for over 50 incandescent lamps and vacuum tubes. Also, arc lights were shown in operation. Naturally, the oscillator also generated the extremely high frequencies necessary for engendering beneficial electrotherapeutic effects.
Refining his theory on wireless communication, the inventor realized that electrical energy could be transmitted in two distinctly different ways, one as radiation through the air, and the other as conduction through the ground. Today, this difference corresponds to FM and AM radio.
As an experiment to verify that FM travels mostly through the air and AM mostly through or along the ground, drive your car into an underpass and turn on the radio. When you switch on AM amplitude modulation, you will probably hear static, whereas FM frequency modulation comes in loud and clear. When he showed my experiments to an audience, Tesla said, it would happen that when I wanted to operate single circuits with some devices, more than one circuit would respond, and people would call my attention to this.
I would then have to say that the circuits were not carefully tuned. Thus, the inventor turned his attention to the problem of creating separate channels.
By studying Herbert Spencer's theories on resultant forces and nerve conduction, Tesla began to realize that he could design vacuum tubes which would respond only when a precise combination of two or more circuits were being triggered. One of the lamps held by Twain was illuminated in this manner, its dual circuit triggered by a corresponding dual circuit created by two cables laid around the room, like the combination of a Safety lock. This invention not only explains the mechanism behind tuning into different stations on the radio, it also explains the principle behind telephone and TV scramblers. In this way, Tesla attained the exclusiveness and non-interferability of impulses. Transmitting messages from an outer circuit to an inner circuit 20 feet away was one thing. Sending information over long distances was another matter entirely. Tesla had realized for a number of years that the Earth carried a charge, and therefore he decided to utilize the planet itself as a carrier of electrical energy.
If this was so and individualized channels could be created, transmission lines appeared to be superfluous. He therefore began to construct many different sized coils to connect to the ground, usually via the water main system, in order to ascertain the terrestrial period of frequency. With an oscillator constructed for this purpose, Martin wrote, "If he has not yet actually determined the Earth's precise electrical charge or capacity, he has obtained striking effects which conclusively demonstrate that he has succeeded in disturbing it. When his oscillations are in harmony with the individual vibrations of the Earth, an intense vibration or surging will be obtained."
Martin ended the article with the suggestion that with this device, not only could information and power be transmitted, but also the weather might be modified. Perchance, we shall call up Mars in this way someday, the electrical charge of both planets being utilized as signals, Martin concluded, quoting Tesla's wish at the finale of the expos.
Classifying Tesla was becoming more and more difficult.
Martin portrayed him in a variety of ways as a practical inventor, a wizard, and an iconoclast. Critics portrayed him as an impractical, visionary enthusiast.
His inventions already show how brilliantly capable he is, one newspaper reported. But his propositions seem like Ahmadman's dream of empire. One is naturally disappointed that nothing practical has as yet proceeded from the magnificent experimental investigations with which Tesla has dazzled the world. LTF Jarvis Patton wrote in Electrical World. B. But his solid accomplishments at Niagara could not be ignored.
The article concluded, before the general public, he stands as a phenomenal inventor from the Eastern world, from whom is expected little less than if he carried Aladdin's lamp in his hand, which, of course, is wrong, and an injustice both to the public and to Mr. Tesla. He has doubtless much importance in store for us, but the difference should never be lost sight of between the search for nature's truths in the lab of the physicist and the reduction of the results attained, however great their promise, to a form suitable for commercial use. If some of the dreams which Tesla and others are cherishing today ever come to realization, the magnitude of the ensuing change in the material life of the world simply defies the imagination.
In Manhattan, Tesla soon caught the eye of Joseph Pulitzer, the German-Hungarian immigrant and owner of the New York World.
Pulitzer sent his newest reporter, Arthur Brisbane, on the interview.
Already one of the most widely read columnists in the nation, Brisbane had recently jumped from Charles Dana's New York Sun. But at age 30, Brisbane would soon also leave Pulitzer to become head shock reporter for William Brand if Hearst's up-and-coming Yellow Fauna.
He met Tesla in July 1894.
While dining nightly at Delmonico's restaurant, the reporter was introduced by Mr. Delmonico to a very handsome young man with a pointed black beard. Brisbane wrote that Mr. Delmonico lowers his voice when he speaks of Mr. Tesla, as Boston cab drivers used to lower their voices in speaking of John L. Sullivan.
That Mr. Tesla can do anything, Delmonico contended.
We managed to make him play Paul one night.
He had never played, but he had watched us for a little while.
He was very indignant when he found that we meant to give him 15 points, but it didn't matter much, for he beat us all and got all the money.
Delmonico noted that they were only playing for quarters, but it wasn't the money we cared about, but the way he studies our Paul in his head, and then beat us after we had practiced for years. It surprised us, considering that Tesla was very proficient at the sport, and had slyly kept that information confidential makes the story all the more interesting.
Tesla could be deceptive, particularly in pecuniary matters. Although the article appeared somewhat disjointed and redundant, it nevertheless aptly described Tesla's habits and appearance at that time.
Tesla would dine frequently at the popular establishment, always choosing a table by the window and usually reading a newspaper.
Brisbane described Tesla's eyes as being set very far back in his head. They are rather light.
I asked him how that could be, as he was a slave.
He told me that his eyes were once much darker, but that using his mind a great deal had made them many shades lighter.
This confirmed a theory on brain usage and eye color that Brisbane had heard about.
Brisbane went on to write that Tesla stoops most men do when they have no peacock blood in them.
He lives inside of himself, and yet the article was adorned with the most fantastic full-body engraving of Tesla standing quiet and stooped, proud as Apecac, illuminated like a virtual Christmas tree. This full-page spread remains one of the most spectacular portraits of the inventor ever concocted, and it caused numerous people to ask Tesla how it felt to pump such huge amounts of electricity throughout his body. I admit that I was somewhat alarmed when he began these experiments, Tesla admitted, but after I understood the principles, I could proceed in an unalarmed manner.
When pressed for details a number of years later at the Harvard Club, the inventor responded, "When the body of a person is subjected to the rapidly alternating pressure of an electrical oscillator of 2.5 million volts, this presents a sight marvelous and unforgettable. One sees the experimenter standing on a big sheet of fierce, blinding flame, his whole body enveloped in a mass of phosphorescent streamers, like the tentacles of an octopus.
Bundles of light stick out from his spine.
As he stretches out the arms, roaring tongues of fire leap from his fingertips as myriads of minute projectiles are shot off from him with such velocities as to pass through the adjoining walls. He is in turn being violently bombarded by the surrounding air and dust."
Tesla was walking a difficult line and revealing contradictory natures, reclusive versus natural showman.
The interest of the press made it difficult to protect against piracy.
He wanted to disclose, for public and historical purposes, his overall goal, but he had to keep vital details confidential.
One reporter who had spent a day with this kindly wizard of Washington Square revealed that Tesla confided to me that he was engaged on several secret experiments of most abundant promise. But higher nature cannot be hinted at here. However, I have Mr. Tesla's permission to say that someday he proposes to transmit vibrations through the earth. Oh, that it will be possible to send a message from an ocean steamer to a city, however distant, without the use of any wire.
Even his laboratory workers were insulated from the details of his secret experiments. After calculating the size of the planet and the hypothetical wavelength of solar rays, Tesla constructed a transmitter with several circuits capable of engendering their electrical charge into the Earth.
One end of the instrument was attached to the ground via the radiator or water main, and the other end was connected to a cable which Tesla brought to the roof of the building as an aerial connection.
With Mr. Dyer's Petrago, his draftsman, in charge of the transmitter, the inventor would take his receiving instruments as far as 5 miles away.
His first experiments were set up on the roof of the Hotel Gerlach, approximately 30 blocks from the lab,
with balloons filled with hot air, helium, or hydrogen to hold the elevated terminal aerial high above the buildings, and a cable attached to the water main of the hotel. Tesla set up his receivers and verified that, indeed, electrical energy could be secured from his transmitter.
Had Tesla taken a reporter with him on any one of these excursions, it is quite possible that the generally accepted history of the invention of wireless transmission would be completely different, because in all of Tesla's years, he never demonstrated before a viewing body any long-distance wireless effects. Still 3 years away from expressing details of his wireless work in patent applications, Tesla had actually hidden some of his plans in patents already secured on his mechanical and electrical oscillators drawn up in 1891 and 1893.
This would present a problem for Michael Pupin, who was also experimenting with resonance effects and the transmission of simultaneous messages. However, Pupin's goal involved the improvement of the prevailing telephone and telegraph lines. He was not attempting to send messages without them.
Pupin realized that by equally spacing pulsations of AC, the rapidity and number of transmissions could be increased greatly. Unfortunately, his February 1894 patent prospectus was easily covered in Tesla's existing inventions and high-frequency lectures.
Tesla had announced in London, in February 1892, that if the wavelength of the impulses is much smaller than the length of the wire, then corresponding short waves would greatly reduce the capacity, making it possible to send over the wire high-frequency currents at enormous distances. Furthermore, the character of the vibrations would not be greatly affected. The creation of a screen to cut the wire into smaller sections would make it possible to transmit many telephonic messages over the transatlantic cable.
These patents and published announcements in no way deterred Pupin. He felt that he had discovered something, and he began a long campaign against the US Patent Office in attempts to bulldoze his way into a legal foothold.
The prize, if successful, would be enormous, as he would have exclusive rights on a way to successfully transmit at the same time large numbers of non-interfering long-distance telephonic and telegraphic conversations over the same wires.
Pupin's nemesis was John Seymour, Commissioner of Patents.
The Columbia University professor's first strategy was to write up a patent application. He submitted it on February 10, 1894, claiming, "I certainly consider myself the first to make a practical application of this principle to multiple telegraphy."
Seymour's reply a few months later was that Pupin's claims are rejected on the arrangement of apparatus shown by patents by Thomson and Rice and by Tesla's article Experiments in Alternating Currents.
Seymour also cited the exact page and figure number, concluding that Pupin had merely multiplied Mr. Tesla's electric light circuits, which in no way was a new invention. Hiring a lawyer to help him put together a legalistic-looking circular, Pupin argued that he had indeed been the inventor of the art of distributing electrical energy by alternating currents. The typeset brief, which resembled an official court document, read in part as follows: Tesla produced luminous effects and did not consider multiplex signaling. He does not disclose several exciting circuits acting on the main line, with means for tuning each exciting circuit independently. The applicant was the first to apply the principle upon which the claims are based, and did more than merely multiply the Tesla electric circuit.
Seymour wrote back, claims 1, 2, and 3 are again rejected on Tesla.
It is well known in the art that several periodicities may be simultaneously impressed on the same line. The examiner can see no more in these claims than a multiplication of Tesla's circuit in a manner well understood in the art.
Pupin was adamant.
He was convinced that he had been the first to invent the obvious, and furthermore, that he had a total right to make use of Tesla's oscillators, as they were now being generally accepted as the optimum frequency generators for long-distance electrical transmissions. By studying each rejection notice by the US Patent Office, Pupin kept refining the language of his patent in order to try and come upon a way that would secure a legal foothold for him. Moreover, Pupin continued to convince himself that indeed this invention was his, altering history in his mind and erasing Tesla in his classroom. Pupin would continue his battle to secure this highly lucrative patent on the means of transmitting many simultaneous messages over long distances. His battle would continue for another 6 years, until after John Seymour retired.
The year 1894 was a banner one.
In July, the spectacular portrait of Tesla appeared in the World. He had major coverage in Electrical World, the New York Times and Review of Reviews, and his AC polyphase system was going to be utilized at Niagara Falls. Tesla had formed a partnership with financiers from Wall Street. He had invited the historical giant's office age to his workplace, and he had made marked improvements in experiments in wireless communication. The year closed with an invitation by Tesla to the Johnsons to come to his shop.
Dear Luca, Tesla wrote on December 21st, "You have not forgotten the visit to my laboratory tomorrow. I hope DVOTK will be there and a number of other celebrities in America's elite."
Anton Volek, 15 years Tesla's senior, had immigrated from his native Czechoslovakia in 1892 to be appointed director of the National Conservatory of Music. Forever homesick, DVOTK stayed in the United States for only 3 years, but during that time he composed some of his most famous works, particularly the New World Symphony. After the performance, DVOTK visited the Wizard's Lab. Christmas and New Year's Eve with the Johnsons would round out one truly remarkable year. End of Nikola Tesla.
Effulgent's glory.
Thank you for watching.